exponential decay functions, just like what we were talking about with exponential growth functions. Growth functions, those bases were larger than one. Exponential decay functions are going to be less than one. Okay, so in terms of between 0 and 1, so we're going to have like fractions or decimals. So I've got like 1/2 to the x, or I've got 1/3 to the x, or I've got 4/7 to the x, or I've got 0.8 to the x, or I've got 0.75 to the x. All of these things are under 1. They're going to be a fraction. Okay. The graphs will be kind of mirror images of their counterparts' growth. So from left to right, the graphs are going to go down the roller coaster. They're still going to approach an asymptote. So, like, at y=0 right there, we're going to have some graphs that look like this. But we can shift those up or down. They can look like that. They could be really steep like this, but they're all going to approach some sort of asymptote down here. Okay. If you would scribble these down, just examples of tables with exponential decay. Notice, from the growth functions, they were getting larger from left to right, top to bottom. Here they're getting smaller. They're getting closer and closer to the asymptote as we go left to right on these things. So once again, get your Chromebook ready to go, get out Desmos, and let's punch in 1/2 to the x. So when I punch in 1/2 to the x, it looks like this, which is the mirror image of 2 to the x. 2 to the x is a growth function, but 1/2 to the x will be a decay function. And if we want to make a table of that to fill in all your notes, I got -5, -4, -3, -2. And down here we'll have 3, 4, and 5. And, since we've been dealing with exponential growth functions, you can tell that this thing's getting closer and closer to y=0. That's going to be your asymptote. We can keep zooming in and see that it's going to get really, really close but not touch y=0. So coming back over here, this was 32. This was 16, 8, 4, 2. Once again, it goes through 0, 1. That's something to take note of. It goes through 0, 1. And then over here, this was 1/2, 1/4, 1/8. And it was giving you decimal numbers for this, and that's perfectly fine. You can scribble in the decimals if you want to. 1/2 is just a really easy one to deal with. And so like at -5, 32 is way up here. -4, 16 is right there. And -3, 8 is right there. -2, 4 is right there. -1, 2 is right there. And then we're getting closer and closer to the asymptote down there. So graph's going to kind of look like this. Hopefully your graph's a little less wavy and it's a little bit smoother than that. Should not be any sort of dotted line right there. So if you were to punch in 1/4 to the x, it's going to be kind of similar, except it's going to be a steeper graph. So if I were to punch in 1/4 to the x, compared to our 1/2 to the x, you can see that the 1/4, the blue one, is steeper than the red one, just like 4 to the x was steeper than 2 to the x. So once again, you can see it's getting closer and closer to 0 right there. You can see that right here, really growing really, really quickly. I guess decaying really, really quickly. Well, once again, this kind of basic exponential is going to go through 0, 1. Going to get larger going to the left, smaller going to the right. So you could sketch that for me. 1/3, same kind of ordeal. 0.8, you can punch that in, see the same thing. And this is the stuff I wanted to get to. So 1/2 to the x plus 4. We know from graphing exponential growth functions that all we're doing is shifting this thing up or down. This is a vertical shift up or down. And so I've got 1/2 to the x, normally has an asymptote at 0, and it normally goes through 0, 1 like this, and it looks something like that. That was a terribly drawn graph, but it looks something like that. And the +4 means that I'm shifting that asymptote up 4, so now it's going to be right here. And my y-intercept is still 1 right above it. So my asymptote is at y equals 4. 0, 5 is my new y-intercept. And we're not going to get specific with this. You can punch that in a Desmo to get specific with it, but it's going to look something like that. And it's going to be just shifted up 4 from that original parent function 1/2 to the x. So 1/2 to the x plus 12. Once again, that asymptote's normally at y equals 0. Now it's going to be at y equals 12. And our y-intercept is 1 above that, so that would be 0, 13. 1/2 to the x is a decay function, so it's going to look something like that. And you could punch the rest of that into Desmos so that you can see all of the points.